Welcome back to Homework Help with Jen. We are doing chapter 4 and we're going to be doing problem number 45 out of chapter 4, and then I'm also going to be sort of tacking on 47 because 47 comes out of 45, and what I'll do is I'll just show you this part for 47 with the different kinds of reactions for one of the problems in 45. Okay, so I've already written out for 45 what we saw in the textbook so that we can work on it. Okay, so if we look at this first one of the things I really like to do when I'm trying to decide what precipitate, if any, will form is I like to break these into ions. Okay, so if we look at this iron sulfate, let's figure out what these are. Well, this is SO4 2 minus, and so this is Fe 2 plus, and this is potassium, and this is Cl minus. Okay, so if we look back at our rules for solubility, we can determine whether or not these will bind to form a precipitate. Okay, if you don't remember your rules of solubility, you might want to pull those out and have them in front of you as we go through this, or at least while you're going through your homework. All right, so we know that iron 2 combined with sulfate is soluble, so it's not going to precipitate out. We know that potassium with chloride is soluble, so it's not going to precipitate out. So the question is, can we mix them up? Now, if we put potassium with sulfate, this is still going to be soluble because of the potassium. And then if we look at an iron chloride, that's still going to be soluble. Neither one of these really tend to precipitate out too much unless they're hooked up with something that will specifically be solid. So in this case, actually, we don't have anything that's going to make a precipitate. So this one would be no reaction, no precipitate. Okay, so let's look at the second one. In this one, we have aluminum nitrate. And so the ions that we have involved here are aluminum and nitrate. And what I have over here is barium and hydroxide. Okay, so we know that our precipitate can't be AlNO3 because that's soluble, and it can't be barium hydroxide because that's soluble. All right, now can it be barium nitrate? Well, it can't be barium nitrate because nitrate is one of our ions that's always soluble. But let's look at the aluminum hydroxide. Hydroxides are often not soluble. It's somewhat rare that they are soluble. There's only a few things that they'll be soluble for. So in this case, we're going to be making solid aluminum hydroxide. Whoops. I just did oops, we can't have charges in our final compounds. Aluminum hydroxide. Okay, so I have the minus here and the 3 plus here. That means that I need 3 hydroxides. And that one is going to be solid. That's the precipitate that I'm looking for in this one. Okay, so now let's look at our calcium chloride and sodium sulfate. Okay, so I have calcium, 2 plus, and I have chloride, 1 minus, and I have sodium, and I have sulfate. And those are the ions that I'm working with here. So again, if I mix and match these, the sodium chloride, that's definitely not going to be a precipitate. But if I look at my rules, I know that the calcium sulfate will be a precipitate. So I would come over here and say, okay, well, my precipitate in this case is calcium sulfate, CaSO4. Okay. And now for the last one, I have sodium chromate. And the ions here are Na plus and CrO4, 2 minus. And here I have aluminum, 3 plus, and my bromide ion, Br minus. Okay, so this can't be the precipitate. This can't be the precipitate. Sodium bromide can't be the precipitate. That sodium's not going to precipitate out. But the aluminum chromate, this one, will precipitate out. So we would say Al2 CrO4 3, big compound, and that's a solid. Okay, so I promised you that I would show you some complete reactions, and what we're going to do is we're just going to do that this part from 47 with D on here. So what we're going to do is I'm just going to take what I've done here and continue it. So this first one is what I often call a molecular equation. This one will be our complete ionic, and then we'll have a net ionic equation. Okay, so I'm going to put in my little pluses and indicate that these are aqueous in all these. There. Okay, see, I had already done some of my work for me. Okay, so over here, when I look at this, I can say, okay, well, I've used my aluminum chromate. Now I need to make sodium bromide, and that's a plus and a minus, one each. Okay, so over here, I have sodium bromide, and that's going to remain aqueous. Okay, so I've made my molecular equation. Now what we need to do is we need to go through and balance it. Here I have 2 aluminums in my product, so I need 2 aluminum containing compounds in my reactant so that I have enough. And then over here I have 3 chromates in my product, so I need 3 chromates from my reactant. So I'm going to sneak in a 3 there. Hopefully that's not too difficult to see. Okay, so I have 3 sodium chromates plus 2 aluminum bromides makes Al2CrO3, and now I need to balance these. So if I come over here, I say 3 times 2, I have 6 sodium ions, and 2 times 3, 6 bromide ions. So that works out rather well. All right, so that is balanced. 3 sodium chromate aqueous plus 2 aluminum bromide aqueous gives me aluminum chromate solid plus 6 sodium bromide aqueous. Okay, so let's fill in our complete ionic now. So I can just bring down, I have 3 and 2, so I have 6 sodium ions, 3 chromate ions, I apologize for getting a little squished, 2 aluminum ions, and 2 times 3, or 6 bromide ions. Okay, now this is the complete ionic. The aluminum chromate here, it's no longer ionic, so we leave it together because it's not dissolved in water, it's solid. But we break up the sodium bromide again for 6 sodium ions and 6 bromide ions. So just remember, the complete ionic shows the complete set of ions, so everything that's still ionic. All right, so that is the complete ionic. Now for the net ionic, what we're going to do is we're just going to include the things that are in our product. We're going to look at the things that change. So we made this. See, we have the sodium and bromide ions here, and the sodium and bromide ions here, and those don't change. So we have our chromates and our aluminums bonding together, and so I like to reverse these so that I have my cations first. And our net ionic is 2Al3 plus aqueous plus 3 CrO4 2 minus aqueous forms Al2CrO4 3 solid.